All right, and so unit 5 is your quadratic. So here's the key information. Okay, you need to know your parts. What I think needs to be, I guess, emphasized here is that you need to understand your axis of symmetry is actually an equation. It's x equal the x coordinate of your vertex. Okay. We do have some formulas when it's in standard form versus vertex form or intercept form. So you do need to recognize what standard form is. It looks like this. We do need to recognize that our axis of symmetry is your line of reflection. So if I have a point here, whatever amount it gets to that point is on the same amount on the other side. Use that property to graph. Also, it's not on here. You have to understand if you have a max, this would be a max because it opens down versus a min. And you also need to know what they're pointing to here are what we call the roots. Okay. Your roots are also your solutions. They're also called your zeros. They're also called your x-intercepts. Okay, so you just got to know they're all the same. Okay, so I did give you some things to remember, like how to get to your axis symmetry in standard form, plug in for the formula, and then remember to plug in the value of x to solve for y. So they've already kind of gave it to us in this example, but we would need the equation to actually solve it. Now, I just want you to find each part if I give you the graph. Y'all are doing a high percentage on in these type of problems. So the vertex, this would be a max because it opens up, and we want the order pair for that point. That happens, so the vertex is -3, comma 2. To get to the axis of symmetry, it goes through that vertex. That's my dotted line. That's a vertical line, so this would be x equals -3. It's always the same as your x-intercept, your x coordinate of your vertex. And then for your root, right here, this is where they cross. This is where it happens to be also your x-intercept. And so we have 2. Now, if you used a bracket like this, you can just list them. This would be -4, comma -2. Now, if you use parentheses, you have to list the order pair, -4, comma 0, -2, comma 0. Okay, so those are the parts that we have to be very familiar with. We have to know what the difference between opening up. This is an opens up. Okay, versus opens down. Okay. So understand if it opens up like this, I'm going to put this little point here. Your vertex will have a minimum, or your value of the minimum is the y coordinate of your minimum. If it opens down, this would be a max. Same thing, it's the y coordinate to get to the max, okay, of that order pair. Now, this is just talking about the points. I'm not really going to go into solving for a because this is kind of what this equation is, but it just talks about some key information here. Know the form, know your vertex. It does tell you how to get to solve for a. Okay, it does. I'm not going to ask you to do that on your final exam review. I do want you to also know that in vertex form, your axis of symmetry would be x equals h, whatever the h coordinate is, okay? And also remember to do the opposite. So like in this problem, this one would be easy. I know the equation on this one because this is a 1-to-1. So they gave me my h is 2, my k is 1. So, and I know I can see that I went over 1 and down 1. So this would be x minus 2, parentheses squared, and then plus 1. Okay. Your coordinate is just another point that you could see on the graph here. This coordinate is also your y-intercept. So this would be x is 0, and then y is the -3. Okay, that's that point right there. That's also your y-intercept. So if I was solving for a, we would plug these in. I'm not going to ask you to do that. Here's what it looks like, okay? I know my y is a -3. Then I would put my a, then parentheses, my x is 0, minus my h was 2, parentheses squared, plus my 1. Well, then I would just solve. Okay, this is just a -2 squared. Okay, but I'm not going to ask you to do that. Okay, we will address that more in the next semester in the spring. So just know your vertex form, know how this affects, your transformations. Your H allows it to shift left or right. Your K shifts up and down. Okay, and your A, you do need to know that your A affects how wide or narrow it opens. Okay, if my A is closer to 0, so a fraction or a decimal, it gets wider. If it's greater than 1, it's skinnier. So you do know what happens when A is greater than 0, or greater than 1, sorry, and when A is between 1 and 0. So narrow, wider. Okay, this one is narrow. Hopefully you can see that. I know this font is bad. This is wide. Okay. And then of course your intercept form, but I don't think this is going to be addressed, but it just shows you the parts. Okay, your x-intercepts are your P and Q. This is just showing how to get to plug in to get to A, but I would add on here to get to your axis of symmetry. Oops, I meant to put that in blue, sorry. Axis of symmetry. This is when you do your P plus your Q divided by 2. But I don't think we're going to hit that. So it's just showing you if I can get those points so that I know my P is a -2 and my Q is 3. You would need your vertex to get to your X and Y. This is plugging it back in. But at least I know my X right here is -1 and 2. Here's what you would do to get to the A. You would plug it in. So 2 equals a A. I don't know that. I know my X is -1. My P is -2. So this is actually going to be +2. And then my X is -1 minus 3. So I would do my PEMDAS. But like I said, you're not going to have a problem like this on the review. On the exam, what I'm going to focus on is really the parts. Okay, your parts, how to get to each thing. So this is what's most important up here. Knowing open up and down, knowing just like your recent tests, knowing your roots, knowing how it's where the vertex is, where to get the axis of symmetry and things like that. So I can't stress enough that your exam is going to be very similar to the review in Alex, almost like twins, not identical, but similar, because I'm going to lessen the questions. All right, so that takes care of everything. Thanks, guys.